Hello, and this is going to be a brief recap of the homework. Again, I'm not going to do most of these questions because hopefully they're fairly straightforward. I'm just going to look over them and talk about them. So 4, 5, and 6 are all basic, very easy simplification. You just collect like terms here. You just do 2a plus 7a, 4c minus 9c, 8 minus 3. There's a plus between the two brackets, so you can just remove the brackets essentially. Same thing over here, there's an addition, you just collect like terms as they are. So fairly straightforward. Question 5 is interesting because there's subtraction. There's just one extra step here where you distribute this negative sign throughout this thing while removing the brackets. So this becomes like m minus n plus 2p, that stays the same, but then you have to do minus 3n minus p plus 7, because we changed the sign, the negative gets distributed. I've removed the brackets. I can now collect like terms and add. So same case over here, except there's just different number of brackets. If you add the brackets, you can just remove the brackets and this is just plus 6x minus 2y. Here you're subtracting a bracket, so again, you just like, when you're removing the brackets, you have to make sure to distribute this negative sign throughout the brackets. So this becomes a plus 3x minus 4y, and then you can just remove the brackets and add everything. So you have 2x minus y plus 3x minus 4y plus 6x minus 2y, and collect like terms, and you should have your answer. So hopefully that's not too confusing, and that's clear. E is a bit interesting. You have a half x plus half or 1/3 y. Again, I'll distribute the negative, minus 1 over 5x plus y. And here you have to know how to add these two fractions. So 1 over 2 minus 1 over 5, common denominator 10. This is a times 5 times 5. So that becomes 5 up here. Here we have a times 2 times 2. That becomes a negative 2. So 5 minus 2 is 3x. And this, hopefully you can see, is just 1 plus 1 over 3, which is 1 over 3, which is, if you convert to improper fraction, 4 over 3. Again, different ways to add fractions, just so that you're good with that, hopefully. I think the next question was question 8, A and B, and then 11. Okay, so determine whether each pair is equivalent. So what you have to do is kind of simplify this and show that these things are the same thing. So for example, I'll do both of them quickly. F of x is this, so I'm going to rearrange or expand and simplify f of x. So I have 2x squared, no like terms. I have a plus 7x minus a 3x, right? So that's plus 4x. And then I have a minus 2 minus 7, so minus 9. G of x happens to be x squared plus x squared, so 2x squared, plus 12, we'll do the 4x, plus 4x, plus 12 minus 17, which is actually a negative 5. Did I do something wrong here? No, I don't think so. So as you can see, these are not equal to each other because they are not exactly the same, and therefore they are not equivalent. This one I can tell right away that this is not equivalent, just because I know that putting a cube into a bracket just does not involve t cubed and 2 cubed. We talked about how even t plus 2 squared is not equal to, t squared plus 4. It's not just t squared plus 2 squared. But just in case, we'll do the long, what is this, t plus 2 cubed? T plus 2 cubed. So I'm going to use a formula for this. If you haven't used the formula, what you have to do is t plus 2 times t plus 2, times t plus 2, and expand everything out the long way. So you got to do like t times t. So you have to FOIL this, and you get t squared plus 4t plus 4. And then you have another step where you multiply everything here with the t plus 2. Again, it doesn't really matter which way you go in the crab claw. You can even do t squared times t squared times 2, 4t times t, 4t times 2, and just going from left to right, it will give you the same answer, multiplication of two things, whatever. So you're multiplying this by this, it will give you the same answer no matter which way you do it. You just got to remember to put all the arrows correctly, all the crab claws in there. And I know you will get the answer t cubed plus 3, t cubed plus 6t squared plus 12t plus 8, I believe, is your answer. Please do that expansion. Let me know. Again, I'm using here the formula that a cubed plus b cubed, I lied. A plus b, the whole cubed, equals a cubed plus 3a squared b plus 3ab squared plus b cubed. This is the formula I'm using. We discussed this in class. And if you use this formula, you'll get this answer right here. And yeah, if you, and again, here, if you do the long expansion, you will get the same answer. This is, I find, a much shorter method because the long expansion does take you a significant amount of time, more than if you use this formula. So it's a useful thing to know, keep in mind. Again, you will not be necessarily given these kind of formulas on any kind of test. However, you could use it on an assignment. It might come in handy if you write it in your chapter summary. Keep in mind, but it's also very important that you apply this correctly. And if you have any doubts, or if you're feeling uncomfortable about applying this formula, just do the long expansion, not the end of the world. Okay, 11. Two equal sides of an isosceles triangle have a length of that. The perimeter is that. Determine the length of the third side. Now, okay, this calls upon some basic mathematical knowledge. People see this like, oh, this isosceles triangle, like, what is all this? But essentially what it's saying, so if we draw an isosceles triangle, like so, right? And let's say these two sides are equal length. Hopefully we're okay with the convention that putting a line over two sides means that they're equal. And I have, what are these lengths? 2x plus 3y minus 1. 2x plus 3y minus 1. So this is also a 2x plus 3y minus 1. I have to find the length of this side, so let's put that as a question mark. And I'm given the perimeter of this guy is 7x plus 9y equals the perimeter. So what's another way of writing? So I'm going to write perimeter, which is equal to 7x plus 9y. But this is also equal to the sum of all the sides, right? So I have this side, which is 2x plus 3y minus 1, plus this side, so one side plus the other side, 2x plus 3y minus 1, and then plus, of course, sorry about that, but I'm just going to put plus this third side, which I'm going to call capital S for my variable. I don't know what that side is, but it's going to be something in terms of like x and y and things like that. So I'm just going to put a capital letter S for my variable there. And now I just expand or do whatever the necessary. So again, I just remove the brackets here because it's adding. 2x plus 2x is 4x plus 6y minus 2 plus s. Now I have to isolate for s, so essentially I move everything over to this side. So subtract 4x, I'm left with 3x, subtract 6y, I'm left with plus 3y, add 2, and this should be our answer at the end. Again, hopefully you're okay with like the people sometimes think to like to think of it as moving this to one side. So if you move the 4x, it becomes a negative 4x. You have to be very careful there, and always think about whether you're breaking up a term or not. That's always the best way. So I've seen a lot of I shouldn't say, I hope none of you are doing divided by 4x at this point, But again, the key is if you're breaking up a term, it's multiplication, division. If you're not breaking up terms, it's addition, subtraction. So here, this is one term, one term, one term, one term. And in moving this 4x, you're not breaking up any terms, right? That's just one term that you're moving as a whole term. So that just is addition, subtraction. Same with this, same with this. If you're breaking up a term, let's say you had like 12 equals like 4x. This is one term, and if you want to isolate for this x, you have to break this up. This 4 only has to come over here. So you're technically cutting this term, which involves multiplication and division, right? So be careful here, and hopefully nobody's too confused by that. Page 95, 4, 5, 6, 7, 8, 10. Let's go to page 95. Where's page 95? Did I pass it? Yeah, I did. 4, expanding. Hopefully we're okay with this. We covered a lot in class. Some of these are very similar to what we did in class. Please review that. I'll just point out that, again, look at this little tricky thing over here. We have negative of 3 minus a squared. Again, this is just negative. You put the bracket and you do 3 minus a times 3 minus a. And interestingly here, you will get the same answer if you do a minus 3 times a minus 3. It's just like 9 plus a squared minus 6a. But there's a minus outside that, sorry. So you have to distribute the minus. But if you use the formula here that we talked about, you know, a minus b the whole squared is a squared plus b squared minus 2ab. Just that changes. I don't think we actually did talk about that, so hopefully you watch both of these videos or extrapolate from common knowledge. Okay, getting a big ob, so hopefully that's okay. What else do we have to do? 4, 5, 6, 7, 8. Expand and simplify, again, very similar, except there's all involve multiple terms. Look at this one, this is massive. But again, you're just doing a, this, that, then you do with the C, then you do with the D, and you're going to have a lot of arrows if you start drawing them, but hopefully you're good with doing that. Again, determine whether each pair of equivalent or expressions is equivalent. We did a similar question in the beginning, so I won't do this now because it's talking about the same topics. You just have to expand this. You have that answer. You expand this. You have that answer, and then you see whether they're exactly the same. Everything has to be the same. All the coefficients, all the variables. I guess technically the order which you write them can be different, but you know we can rearrange that order to proper form. So that's, again, fairly okay. Is the equation, we do have to do 7? 7 looks complicated. We do have to do 7, interesting. 7, 8, and 10. Ah, look at that. Interesting question. Is x minus 3 squared equal to 3 minus x squared? Explain. So here, I will touch upon an important point here. So we will note that x minus 3 is the same as negative of 3 minus x. Because we note that if we apply this negative into this bracket, we get negative 3 plus x, which is just another way of writing positive x minus 3 if we rearrange the terms, which happens to be equal to this. So like I said, it's important to note this. This will come in very, very handy. Please put a star over this. So it's very crucial that we note that x minus 3 equals to the negative of 3 minus x. And that applies for like everything. If you have like a binomial that's separated by a negative sign, if you take the negative out, you just interchange the terms, you flip the terms around. And we will note, so what this question is asking for is that equal to that squared. So if we take x minus 3 and then we square it, and then we take 3 minus x and then we square it, is that the same thing? So we note that 3 minus x is just negative of x minus 3, right? And now we square this. And what does that give us? So we know that this is negative of x minus 3 times negative of x minus 3. which is again just x minus 3 squared, but a positive because the negatives kind of multiply each other to give a positive. So we know that these things are equal to each other. This is not, in fact, the case when we have a cubed, because if we have x minus 3 cubed and then 3 minus x cubed, we know we can write the 3 minus x as negative of x minus 3. Again, we can go either way here. Obviously, when I said it, I went this way, but either way works. And then here we have a negative times a negative times a negative. So 3 negatives makes a negative. And then we still have the x minus, whatever that number is. Like, I don't know. You can expand this out. You don't have to. But we note that this is not the same as here because there's an odd number of negative signs. So that's the understanding for question 10. I jumped a little bit, but... okay, this is associative property, expanding, simplifying in 2 different ways. This is again saying that when you have a number and 2 brackets, you can either do this first, like move the 19 in here, and then do the FOIL, or you can do the crab claw first, and then multiply all of that by 19. I will tell you that doing the crab claw first is usually easier because these are smaller numbers. As soon as you multiply 19 into 5 and 7, that just becomes like, like 95x plus like, 153 times, what did I say? 95x plus 153 times 3x minus 2. And I mean, you could do this. It's not the end of the world with the calculator, but again, bigger number is more annoying generally. So I would do the 5x times 3x is 15x squared, negative 10x plus 21x minus 14. Simplify like terms first in that bracket, and then multiply 3 terms by 19. So hopefully you're doing that properly. Let's look at this thinking question. Is the equation equal true for all, some, or no real numbers? So first we have to expand this. There's no other way to go here. We'll do x minus 1 in brackets, and then we have an x to the power of 4 plus x cubed plus x squared plus x plus 1, I believe. Okay, so let's see if this is equal. So we have to expand this. So we're going to do, again, our crab claw, 5 things, which is basically x times all of this. I kind of know that's going to give me like x to the power of 5 plus x to the power of 4 plus x to the power of 3 plus x to the power of 2 plus x to the power of 1. And then I just do a minus 1 times all of these guys, which is minus x to the power of 4 minus x to the power of 3 minus x to the power of 2 minus x to the power of 1 minus 1. So hopefully we see that here there was an x because I did an x times 1. That was my last term. Here is just negative 1 times 1 is my last term. So again, collecting like terms, I have x plus 1 x to the power of 4 minus 1 x to the power of 4 plus 1 plus 1 plus 1 minus 1 plus 1 minus 1, and I'm left with x to the power of 5 minus 1. So is this true for all, some, or no real numbers? That's an interesting question. So I know that these expressions are equivalent, right? If I expand and simplify this, I get the same thing as this. Now you just have to think, okay, is this a test question? Is there some kind of trick to this? I don't believe that there are any tricks. I think this would work essentially for all real numbers. Hopefully I'm not wrong. If you do a 1, you get 1, 0. Yeah, I think this is true for all real numbers. Just because the expressions are equivalent, if you expand one, you get the other. There's no tricks here. It's just true for all real numbers. That's kind of anticlimactic. I thought that question would be a lot harder. But then again, it goes to show that you never want to look at a question and kind of to try and judge it before you actually try and attempt it. Maybe it ends up being super easy. You never know. So that was an exciting finish, I'd say. Kind of very nice. Sorry about the long video, but again, there was a lot of homework to cover. So I'll try to keep it short from next time. I'll point out at 13 minutes that there's something important I talk about, so we'll go over that. But yeah, it's good that I guess I'll probably point this out in class as well. This x minus 3 is negative 3 minus x. That's kind of super important. So I will see everybody in class. Peace out.